7 Caillou series. Next challenge is called Simple Fun number 154, 0 and 1. You have a string that consists of zeros and ones, like a binary string, right? Now choose any two adjacent positions in the string. If one of them is 0 and the other is 1, remove these two digits from the string. Return the length of the resulting smallest string that you can get after applying this operation multiple times. Note, after each operation, the remaining digits are separated by spaces and thus not adjacent anymore. See the examples below. They give you an example input, 0, 1, 0, 1, 0, and the result should be 1. So you can think of it like when a 0 and 1 opposites are next to each other, they kind of consume each other and cancel each other out. It's kind of one way you could think of it. So if you're looking from the left, you got a 0 and a 1. And notice here, they're just absent now. They both gobbled each other up. They canceled each other out. Then you come to the next two because that 1 was gone, right? Then you look at this, and 0 and 1 gobble each other out, hence another 2 spaces. And then finally, all that's left is 0. I'm sorry, it's hard to highlight, 0. And there's nothing, no ones or other zeros to pair it with, so that's the final, that's what remains of the original input, and you return a 1 because there's one character. So hopefully that's clear. Look through the other examples if you'd like to, and this is a good example to show you 2 in a row. Notice the ones don't cancel each other out. One of them survives, but you hit a 1, 0 here, and those two, poof, disappear, right? So look those over as much as you need to. Output's an integer. Yep, we know that, right? Input is the parameter list here for the method, and the return type is integer. The minimum length of the string that, yeah, they already said that. So I think you know what this is. Go ahead and knock it out. Come on back when you're ready. I'm going to just use a simple for loop to go over the string, look at characters, and come up with this count. Now, they sort of describe it as, you know, you're removing characters and replacing them with blank spaces. But if you think about it, it's kind of more work than you really need to do. All they need to know is what the size of that string, how many characters that string would have left. So what I'm going to do is just count how many characters would survive, but not actually maintain a string and blank characters out and something like that. This struck me as more work than I needed to do. So to that end, I'm going to make a local variable. I'm going to call it count, and this is going to be the final thing that I return. I'm going to scan that string and increment this when I determine that a character survives, so to speak. I'm going to start at the left and just proceed to the right. And you can think of it, when I do it, I'm going to have a sliding window that starts from the left, and I'm going to examine the current character and and one in front of it. So I have this size 2 window that I'm looking at any given time in my loop. So the first time through the loop will be like this. The second time I'll be looking at these 2 characters, possibly, right? If I blank a couple out because they're alternates, then I'll jump ahead and start where characters remain. I won't go to an index that won't have a character in it. And I think that'll be clear when you see the for loop. But this is just the way I thought about it. I'm sure there's 100 ways you could go about this. So what do we know we have to do? Well, like I said, we're going to go over the string. We got to look at all the characters. So let's do that. We know how to set up a for loop, s.length, and ++i. Okay. I'll define my scope with these curly braces for my for loop. Now, like I said, I want to look at 2 characters at a time. And because I'm doing that, I'm sort of looking at 2 cases here. If I'm looking at 2 characters at a time, I don't need to look at 2 when I'm at the end, right? Because if I try to look 1 past the end of the array, I'm going to go out of bounds, and that's going to cause trouble. So I only need to do it to s length -1 in terms of looking at pairs. But it's not that, don't worry, I'm not going to just forget about potentially having one character at the end. We'll cover that too. So my two cases in here are if I is less than string length minus 1. And if this condition is true, it means we've got at least two, we can look at least one ahead, right? We can use that sliding window. And if it's not in there, that means we have, we're on the actual final character, right? If it's not less than s length minus 1, that means we're on the last character. So, okay. We know we need to examine the current character with the one in front of it, right? So how would you check the next index? I plus 1, right? Si gives us the current character, and I plus 1 gives us the next character. And if they don't match, this means that I have to sort of delete the two values, both Si and Si plus 1. And the way I'm going to kind of mock that, remember I'm not doing anything with strings here, I'm going to increment the index here. And that normally happens when we reset to the top of the for loop, right? This runs every time. But by doing it an extra time here, then when it goes back to the top of the for loop, it's going to bump again. So effectively, I've moved from the current index two places, because I've incremented twice here. So that in that way, I jump over, and I'm not trying to examine a character that should be deleted. That's sort of how I handle that. And then otherwise, if the two characters are equal to each other, then I know I can increment my count because of this current index, right? I know it doesn't, it hasn't hit an opposite and sort of canceled out. So in that case, I'm going to bump my count. Okay, good. So this will go through that sliding window. But just keep in mind, like with this first example, right? I'm looking at 2 at a time in my algorithm. And I'll delete in this case, right? Si is 0 when I equals 0. I'll look at these two. I'll see their opposites because I'm looking at Si plus 1. And I'll delete them. I plus plus I, so I goes to 1 when this executes. And then it's going to go back to the top of the for loop, right? There's no other statements to run. And it's going to increment again to 2, so that by the next time it gets into the next loop, we're already at index position 2, which you can see has the effect like I just skipped the first two characters. Right? So I don't have any kind of potential to count that 1 that shouldn't be counted. That's sort of how I get around that. But then we have the same thing, right? Happen at I equals 2. The same thing is going to happen. You're going to see they're not equal to each other. You're going to bump this value. So that's going to go to 3, right? You're going to come around to the for loop. It's going to bump as part of the bump that happens every time you restart the for loop. So I actually goes to 4. 0, 1, 2, 3, 4. So you see you jump to this last index. And so the problem is that we can't just ignore that last 0, right? So if we get to this point and we can't, there's no potential for it to be canceled out, I'm going to be sure to bump my count one more time. And then provided that we went through the loop and we finished, we've gone through all of our indices, we can simply return the count. Remember, because all they wanted was that number, that integer value representing how many characters would have survived. And in doing it this way, I just didn't have to maintain a string and delete characters and all that. And I know it's not a big string, but that's just kind of the way I thought about doing this. I didn't want to do extra work that I didn't have to. And so just again to be clear, with this condition, if you hit the else part, right, that means that I is s length minus 1, i.e. the last char. So once you get down here, you're at the last character. And so it works out, let's see, they didn't give us an example. Oh yeah, sort of in this example, right? One would survive, those two cancel out, those two cancel out. So you're left with a 0 at the end, right? And so you have to count that, and that's what this last bit does. It'll just give us that count when there's one remaining. And you don't have to worry about it counting in the case where it shouldn't, because this how I jump ahead on mismatch will basically kick us out of the for loop when needed, so we don't make this count when it shouldn't happen. Remember when we analyzed the step-by-step, it jumped ahead 2, so you can imagine if it jumps, you're on the second to the last one and it jumps ahead 2 slots, you sort of jump right over this condition, right? And so this loop doesn't run and you don't get this extra count. I just want to try to clear that up so it's not confusing. It's not just automatically counting the last one. So I will go ahead and give this thing a spin. Green. All right. Give me the attempt. And green again. Good. So yeah, it's okay if you were doing string work and sort of replacing characters with empty characters, space character, and then at the end maybe you had some thing that looped over all the characters again and counted anything that wasn't a blank. But you can see how you're kind of going through the input multiple times there. And if you can avoid it, that's good. But really at this point in the game, if you're solving the challenges on your own, that's outstanding. You should be really proud of yourself. So go ahead and submit to collect your honor. And you just go through other people's solutions, see what else you can learn. There's probably a lot of different things here. Yeah, look at, they're already using rejects and regular expressions and whatnot. Replace with, yeah, that's super handy, right? Replace. Why didn't I do that? But sometimes it's good just to make your own, and it's all good. So yeah, hit me up if you have any questions or need any help, or show me what you came up with. Otherwise, I'll see you in another challenge. Thanks for watching.